Saxon's Trig, Lesson 100, is about product identities and more sum and difference identities. And I thought we were finished with these, but I don't, because this is so close to the end of the book, I don't use them a great deal, and I almost tend to forget that they're here in the list. So in the first example, they want you to develop an identity for a sine A cosine B problem. What happens when you have these multiplying? Now, I'm going to develop this first one, and then you're going to understand how the others work, and I'm not going to do examples 2, 3, and 4 where it wants you to develop the other 3. We're just going to jot them down in our notes to keep them, because you're going to understand very quickly where they're coming from. So sine A cosine B, I need to look in my original in the original 4 for where I have in the answer part a sine A sitting next to a cosine B. Well, that happens to come from sine of A plus B and from sine of A minus B. So in both of their answers, they have this sine A and this cosine B sitting side by side. And you are, I probably should have written the long one out. Yeah, okay, let's do it that way. Sine of A plus B plus the sine of A minus B is going to give me, so the long equation for sine A, let's write it underneath because it's definitely long, is sine A cosine B plus cosine A sine B, and we are adding the A minus B, so sine A cosine B minus cosine A sine B. So here are these two added together. We were looking for the sine A cosine B combination, which we have here and here. So what happens with these? Well, they are one positive, one negative of the same thing. So they're crossing off. So basically, when I'm adding these two pieces together, I am getting 1 plus 1 is a 2 sine A cosine B. Now, ultimately, what I want are these two alone, not with the 2. So that means I'm going to divide both sides by 2, which means that all of this is basically multiplying by a half. That's showing that divide by 2. So if I put the addition of these two together and I take half of it, I get the sine A cosine B that they're looking for. Now that you kind of understand how they're developing them, the others are cosine A sine B. You know what, I may just rewrite this one so I can have them all in order for you. Sine A cosine B equals a half with the sine of A plus B plus the sine of A minus B. Now we are doing cosine A sine B, and that's going to have that same half in front of sine A plus B. And it is minusing with sine of A minus B. Then we have cosine A cosine B, and that's going to be a half of cosine A plus B plus cosine A minus B. Just want to make sure I've not flipped. It's so easy to get the A's and B's backwards. Half cosine AB. Yes, okay. And then the final one would be your, started to write cosine again. Sine A multiplying with sine B, and that is going to be a half of cosine A minus B with the minus cosine of A plus B, because we just basically needed to change those signs. All right, so those are those 4. Then they move into part B, More sum and difference identities. Okay, so now when you look at what they've labeled K through N's formulas, you see that you've got stuff similar to what I have for this set, but now instead of our A's and our B's, we've got some fractional things which are x plus y over 2. So in example 5, it asks you to develop the identity for sine of x plus sine of y, and you have to get those sine x and sine y's coming from the A's and B's. All right, so instead of in our originals where we had, okay, so this one where I wrote sine of A plus B out, which was here, instead of the A, we are going to, or I'm sorry, instead of the A plus B, we're going to substitute that as an X. And where we have an A minus B, we are going to substitute as a Y. And then I can manipulate the problem to be solving for, but it gives me in the answer parts where I write them out the long way, this becomes an x plus y over 2, and for the y one, it becomes an x minus y over 2. All right, so in the end, you get these. Sine of x plus sine of y comes from 2 sine of x plus y over 2 and multiplying with cosine of x minus y over 2. Then example 6 wants you to do sine of x minus sine of y, and that gives you 2 cosine x plus y over 2 multiplying with sine of x minus y over 2. In example 7, they want cosine x plus cosine y. So that gives you 2 cosine of x plus y over 2. Multiplying with, here we go again, cosine of x minus y over 2. And I'm going to cram it here on the bottom. The last, cosine x minus cosine y, is going to give you negative 2 sine of x plus y over 2 multiplying with the sine of x minus y over 2. And I'm fairly certain these are the last of all of those lovely formulas. And if you want to go a little more in depth, there they all are. And I would definitely add this to my notes. But if you want to go a little more in depth as to figuring out exactly how they did those substitutions and manipulations, each of them are there in those examples 5 through 8. But at this point, I'm just going to give them to you in the list so that you would have them to use them and manipulate.